Hello everyone, my name is Edgar. In this quick Wireshark walkthrough, I'll show how one Wi-Fi capture reveals what each layer is doing. We're going to be looking at switching at layer 2, routing on layer 3, transport on layer 4, application data on layer 7, as well as how encryption hides upper layer details. So let's jump right into it. As you can see here, I'm in Wireshark. We're looking at datum at frame 8. This is the 802.11 data frame, so layer 2, we're dealing with MAC addresses. Here is the transmitter address. It's going to be the Cisco switch that has the MAC address 7E50. Here is the receiver address. The receiver MAC address is going to be this ASCII compute client that has the MAC address ending in 7735. Layer 2 is what let devices on a local network deliver frames that are on the same LAN or WLAN. This is the layer switching and Wi-Fi forwarding relies on. Next, we're going to be jumping to layer 3, the networking layer. Here we can see it's using IPv4 with the source IP being 192.168.100.51, and then the destination IP is going to be 192.168.152. This is what routers use for routing between networks. It's essentially answering the question, where on the network layer is this data being forwarded to? Okay. Next, we're going to be jumping to layer 4, the transmission layer. We're looking at transmission control protocol. It is using source 20, which is file transfer protocol, and the destination port is going to be 1105, which is either going to be TCP or UDP protocols. These are connection-oriented protocols. It's basically delivering packets in order, and it's ensuring that the packets are being delivered. Port identify which application slash processes is talking to each host, and TCP provides a reliable delivery using sequence numbers and acknowledgements. Okay, and then we're going to be looking at layer 7, the application layer. Now, looking at this, it does bring up a big security point because this frame is unencrypted. We can actually read the application data itself. Wireshark is showing this FTP data, and the payload includes the readable text. So this one has the payload with the plain text. These are the times that try meant soul. That's that's layer 7 content being carried over the network in plain text protocols like the one we're seeing right here. Anyone can capture the traffic and they could potentially read this. So it does bring up a big security issue. Okay, now let's jump towards frame 136. Now I'm on frame 136, which is an encrypted 802.11 data frame. Even when the payload is encrypted, we can still see layer 2 MAC addressing here. It's still visible on the wireless network, so to ensure that it does arrive to its destination. We can see for example, we can see the source address. So for source MAC address could be this ASCII compute client 7735. We can see the destination address, which is right here. It's going to be the scam techno client with the destination MAC address of 673C. And then I also want to bring up this receiver address. This could be the same Cisco router that we were looking at earlier, which plays a part from forwarding data frames from one client to another that are on the same network. They're on the same LAN or WLAN. Now, in an unencrypted 802.11 data frame, the IP and TCP headers would normally be visible. They would normally appear right after looking on this level 2 header right here. This is typically where you see the source slash destination IP addresses and TCP ports. This is an encrypted frame. The upper layer data is protected. So instead of seeing the IP and TCP details, we can only see the web parameters right here, the wired equivalent privacy as well as this data blob right here, this hex, this encryption right here. The IP addresses and TCP ports, they still exist, but they're inside the encrypted payload. So Wireshark can't decode or display them unless we have an encryption key. In this case, we don't. So we can only see this data blob, this hex right here. We can't decrypt it because we don't have the encryption key. That's why the normal layer 3 and layer 4 sections are missing. They don't appear here because it's all encrypted. A lot more, a lot more secure method of data transmission. So this frame shows the big security differences. Layer 2 addresses, layer 2 addressing is still visible for delivery, as we saw here, but layers 3 and 7 are hidden when encryption is used. So overall, this assignment shows how Wireshark ties a Wi-Fi capture to the OSI layers. In frame 8, the traffic was unencrypted, so we can see the IP and TCP details with the application payload. In frame 136, layer 2 MAC addresses are still visible, but everything else above it is encrypted. That's the key takeaway for entry level troubleshooting and security. Thank you so much for watching.